Hi guys, this mini lecture is on calculating concentration. What's concentration? Well, really what you're trying to do is measure the amount of material in some other material. So normally amounts of material, of course, can be worked out in things like grams or moles. And then in some other material, normally the calculation's done using a volume like litres. So that's pretty much the example I'm going to give you here, where we look at a thing we call molarity, which is just the number of moles in a litre of solution. Okay, so I guess again, it's a bit of the old terminology thing. You're looking at something new, so there's a bit of terminology to go along with it. So what is concentration? Then it's measuring the amount of one substance, and the smaller amount of substance is normally referred to as the solute, and it's dissolved in some other substance, and the larger amount of material that it's dissolved into is normally called the solvent. The two together forming what's referred to as a solution. As I said before, the common units of concentration for this are moles per litre. You can use an abbreviated form of moles per litre, and it's called molarity, and it's given the symbol big M, but big M is the same as moles per litre. One thing you can do sometimes is rather than writing the concentration of something you can actually use a shorthand notation, and what you do there is you put square brackets around the material in question. So in this case, this here means the concentration of sodium chloride, and normally what you do is write equals and then whatever it is in moles per litre or in molarity. Okay, so let's do an example calculation here. So here's the question: what is the molarity of a solution obtained when dissolving 25 grams of sodium chloride in water to give a final volume of 300 mils? So we could in fact give the concentration of chlorine as sodium chloride as being 25 grams per 300 mils, but this time we want it in molarity, so we want it in moles per litre. And so the problem we've got at the moment is that we've got sodium chloride in grams and we've got water in mils, and we want it in litres. So how do we do it? Alright, so the first thing we want to do is calculate the number of moles of sodium chloride. And by now you should be familiar with how to do this. Basically, if you see the mass of a particular compound, you'll know what the formula is by looking up the atomic masses and therefore corresponding molar masses in the periodic table. You can work out what the molar mass of that substance is and then calculate the number of moles. So here we go, here's the molar mass of sodium chloride. You look up the molar mass of sodium, you find it's 23 grams per mole. You look up the molar mass of chlorine, it's 35.5 grams per mole. You add the two together, we're getting 59 grams per mole for sodium chloride. So that's the molar mass. We know what the mass is, it's 25 grams. 25 grams there, so therefore it's going to be 25 grams divided by the molar mass, which is 59 grams per mole. You'll see here that the grams cancel out as you would expect, and it's actually 1 over moles, which means the units are now in moles, which is what you're after. Of course, if it says number of moles of sodium chloride, you want your answer to be something moles, and it is here. And the answer in this case, or at least the magnitude of it's 0.42. So we've now got our number of moles. Now what we're after is the number of moles per litre. At the moment, we've got our volume in mils, so we've got to convert our mils to litres. How many litres have we got? Well, there's 1,000 mils in a litre, therefore it's 1,000th of a litre equals a mil. So I've got to take 1,000th of this value, so it's 1, 2, 3, so it's going to be 0.3 of a litre, and there's the number of litres now. Now to finally calculate the molarity, what we're doing of course is we're taking the number of moles, 0.42, and the number of litres, 0.3, and you're dividing one by the other, and you can see you get the right units, moles per litre. So the answer there is 1.4 moles per litre, or you can write that as 1.4 molar, however you wish. Okay, now there's another way of doing this. It's kind of around in reverse a little bit. You ask yourself the question, what mass of copper hydroxide must be added to 350 mils of water to produce a 1.2 mole per litre solution? Alright, so to do this one, we've first of all got to work out how many moles of copper hydroxide we're dealing with, and then of course from that we can back calculate and work out the mass. Whoops, sorry about that. We can back calculate and work out the mass. So how many moles of copper hydroxide have we got in this solution here? Well, to work that out we multiply the concentration by the volume. So the concentration is 1.2 moles per litre. The volume is 350 mils, which is 0.35 of a litre. Remember, we've got to make sure we get the right units there. Now just double check. This will be litres divided by litres, so they'll cancel out. So you'll be left as with moles as your answer. So that's correct. We've done the calculation correctly. Always check to see that your units are right. So it's just merely a case then of multiplying 1.2 by 0.35. We end up with 0.42 moles. The question asks what mass of copper hydroxide, so it's one of these conversion calculations again. We know the number of moles of copper hydroxide. We know or can calculate the molar mass of copper hydroxide from its formula. So here we go. The mass is going to be equal to the number of moles, 0.42, multiplied by the molar mass of copper hydroxide. So again, you look those values up in your periodic table. It's 63.5 or 6, whatever you want to call it, plus 16 plus 1, multiplied by 2, plus 16 times 2, because you've got 2 lots of oxygen there, 1 times 2 because you've got 2 lots of hydrogen. And when you calculate all those numbers out, hang on, let's just check the units. We've got moles here divided by moles, so they cancel out. Your answer will be in grams, and that's what you want because you're looking for a mass. So the answer is 41 grams. So using essentially the same sorts of techniques with these back calculations and looking at relying on the fact that you can work out the molar mass of something simply by looking up the periodic table, you're able to solve problems such as this. Okay, that's the end of this little mini lecture.